All righty, friends. Welcome back, welcome back, welcome back. So we're continually working our way through the idea of integration. But we're going to look at a special type of one today. It's called integration by substitution. So we said that there is no integration that has a product rule, which is true. And there's no integration for a quotient rule, which is true. And we said there's no integration for a chain rule, which is technically true. And here's what I mean by that. If I ask you to take the derivative of f of g of x, you guys hopefully by now would recognize that that is the chain rule. So we take the derivative of the outside times the derivative of the inside. And if I wanted to undo a derivative, we can work backwards. Well, then I would integrate. So if I integrate the result, I should somehow get back to what I had at the beginning. So if I integrate all this right here with respect to x, don't want to forget that differential, I should be able to get to this, because they should, again, a derivative and an integral, they're inverses of each other, or in kind of an inverse operation type thing of each other. They undo each other. But the question I got then is, okay, I know where the dx goes. That's just saying I'm doing the derivative with respect to. Whatever happened to g prime of x? Where'd that go? So let's see if we can't try to figure out what happened to it, because it just can't go anywhere. In order to do that, we're going to take this thing right here. We're going to do what we call a U-substitution. So we're going to say, let's let U be equal to g of x. And what if I take the derivative of both sides with respect to x? If I do that, I end up with du over dx equals g prime of x. So I take both things with respect to x. And if I want to get that du by itself, I can multiply both sides by dx. So we would end up with du equals g prime of x dx. So by the way, when I do a U substitution from here on out, because we'll be doing this quite a bit today, I'm not going to do the whole du over dx. Oops, made a mistake there. I'm going to keep it truly in its differential form. So I'm not going to do a true derivative. I'm going to just do differentials. So I'm going to use du equals g prime of dx. I'm just going to literally take myself right to the differential. So just so you're aware, that's going to be kind of what we're doing today. Anyways, so if we take this idea here, and let's see here. Let's talk about what we're doing here. So then what would happen here is this f prime of gx if I use this U substitution idea, what ends up happening is, let's see here, this gx, we said we ended up letting that be equal to u. That's what this was right here. But if you notice, du is equal to g prime dx. So here's my g prime dx. That's what du is. So if I integrate this derivative, I end up with just the regular old function plus c. Now, we come back here again, and remember that u is equal to gx. I can plug it back in with f of g of x. So that g prime of x, it wasn't necessarily that it went anywhere. It was still there. It's just that g prime of x, it was part of the differential of the composite function. And just like d of x, we ended up essentially dropping it away as we do our integral. Now, how's this going to work for us today? Well, let's throw a problem up here just for the fun. What are we looking at? And today is going to be kind of a drill and kill kind of day. I'm going to throw a lot of problems at you. So, in order for us to kind of get this idea, we need to do just a little bit. So, we're going to use this u, but if we try to come back and interpret what this u means, we're basically saying that u is really it's the inside function for f of x. That's really what we're saying this u value is. It's this u is going to be used to substitute inside the inside function. So as we're doing this, one of the things we need to always ask ourselves is what function is inside. So let's take this problem right here. First of all, I want to rewrite it again because I want to take that 4x and I'm going to go ahead and put it next to my dx. I can rearrange this order anyways. It's just multiplying. And when I do that, can you see what function is the inside function? So think of composites. What function is our inside function? In this case, that one is inside parentheses. It's a little bit easier to tell. Let's let that be our inside function. So we're going to make that u. So right now I got a problem that I definitely do not want to go ahead and take out to the 8th power. There's no binomial expansion theorem that I'm going to want to do for that. I mean, I guess I could, but no thanks. So du would be equal to 4x dx. We just do the differential. And if you notice, there's our 4x dx right there. So if I do a little bit of substitution here, we said let u be the inside function. So here's my u. And 4x dx, well, that was the same thing as du. Now, the problem is a lot easier to integrate. By using a U-substitution, I turn it back into a power rule so I can actually integrate the entire thing. So I have 1/9 u to the 9th plus c. And from there, I'm just going to go back and I'm going to plug in what u was now into my problem. So u was 2x squared minus 5. That's what we mean by U-substitution. You take whatever function is quote unquote on the inside, and we can use that to evaluate everything that's kind of on the outside. So this is going to be what we play with today, and we're going to do quite a few of these here because everything we do pretty much from here on out is based off this idea. We have to have this idea down. So let's have you try a couple here. 2x times the cube root of x squared minus 1 dx. And let's try this. 4x plus 3 2x squared plus 3x minus 1 cubed. All right, why don't you guys go ahead and pause the video and see what you can do with each of these. All right, let's see how you did. First up, I would always take these again, and I would rewrite them. I always want pretty much the regular function to be by itself, or to come first. Anything that's outside of parentheses goes to the back. So here's my inside function. So that's what I'm going to make u. So u is x squared minus 1. We do our du. We get 2x dx, which is that right there. So now we do our u substitution. So u to the 1/2, sorry, 1/3. Holy red bucket, let's see if we can't fix that up. There we go. Du. So 3/4 u to the 4/3. We integrate our power rule again, and then we go back and we plug it in. So really the only rule we still have is just the power rule. And C was x squared minus 1. Let's see how you guys did on the next one. So we have this, I'm going to rewrite this again. I'm hoping you guys can agree with me that this 2x squared plus 3x minus 1 was the uglier of the functions. Some of you might have been thinking, wait a minute, Williams, I kind of see a quotient rule. You might, but remember, there is no quotient rule. Not for integrals. There is for derivatives, but not for integrals. All right, so here's my inside function. So that's what I'm going to make u. So u is 2x squared plus 3x minus 1. So du is 4x plus 3 dx, which again I have right there. Hopefully you guys aren't feeling too terribly bad about all this right now. And we're going to do our plug everything in here. So I have u to the negative 3 du. So I have u, whoopsies, and have negative 1/2. Yeah, let's not do that. Let's write it this way. U to the negative 2 divided by negative 2. I'll bring out that negative 1/2 here in a second. So we're able to rewrite it. What was u equal to? 2x squared plus 3x minus 1. All right, friends, here we go. Let's try a little bit more of the fun and excitement here. What if I give you something that looks kind of like these? Let me write a few up here. There we go. And let's do 8x. Two x squared. Oh. 2x squared plus 9 plus 3 to the 9th dx. Something like that. All right, hopefully first look you can guess what the inside function is going to be. So here's my u. So u is 5x plus 9. That means du is 5 times dx. But if you notice, I just have dx here. So I need to get dx by itself. So I'm going to divide by 5. So now I get 1/5 du equals dx. Sometimes we have to balance our expressions a little bit more. Sometimes they're not quite as just cut and dry as just straight u sub. Sometimes we have to play just a little bit more with them. So we have u to the 5th times 1/5 du. So now the 1/5 can come outside. And we end up with u to the 5th du. Now, again, it's back to being our straight power rule. Notice how everything ends up becoming some sort of power rule, or eventually when we get there, some sort of trig rule. You know you've done it right if everything eventually turns into a power rule. So we get 1/30 u to the 6th plus c. All right, why don't you guys go and pause the video here and just see what you can do with this next one. Go for it. All right, let's see how you did here. I mean, you might have looked at it a little bit and going, wait a second, I'm not sure I kind of am following everything on. Oopsie, that's an ugly looking 3. I'm telling you, I have trouble with 3s, man. So I'm gonna move my 8x to the back here. So I can see my u. My u is always my inside function. So there's u. So u is 2x squared plus 3. So I have du equals 4x dx. Well, friends, I got an issue. Notice I have an 8 there. I have 8 times x dx. So which means I'm going to have to multiply both these by 2 to get it to match up to my 8x dx. So now I have 2 times du equals 8x dx. So really, we're just kind of doing a separate side problem to make everything kind of balance out. And once it's all balanced out, then we can go ahead and do our substitutions. So I have u to the 9th times 2 du, which I'll bring that 2 to the outside because it didn't need to be there. And I can still integrate the rest of it here. All right, so 2 times u to the 10 over 10 du. Oops, no du, plus c. So we have 2 to the 10th times, and you could simplify that 2 to the 10th to 1/5 if you wanted to, it doesn't matter. 2x squared plus 3. All right, let's have you guys try a couple of those, I think. I think that'd be just about good here. Let's see here. Let's go x times the square root of x squared minus 3. Like I told you, today is a drill and kill day. Just got to practice the skill. And 1 over 4x plus 3 to the 7. All right, go for it. All right, let's see how you did. So we have our x squared minus 3. I'm hoping by now we're starting to get a little bit better at seeing what the inside functions are. times x dx, which means it's right there. There's my u. So u is equal to x squared minus 3. That's an ugly u, folks. Sorry about that. So du is 2x dx. Well, I only got 1x dx here, friends. So move the u to the other side. So what 1/2 du equals x dx. So we're going to go through now and do our substitution for our differential. And we're doing a lot of these, friends, because this is where people tend to get messed up a little bit on integration. If they start to go a little haywire, this is when it begins to happen. There's a couple other spots along the way where we got to be careful, but this is where majority of the issues will start. So we have 1/2 times 2/3 u to the 3/2 plus c. So 1/3 and we will plug our u in there. All right. Let's take a little gander at this one down here now. You guys have had a chance to do this one as well. I don't do quotient rules, so I'm going to bring it up to the top. Make that a -7. All right, there's our u value. So du equals 4 dx. Well, it doesn't quite match up. I only got a dx. I got to move the 4 to the other side, so 1/4 du equals dx. Now we do our u substitution. Again, I don't want today to be overwhelming because we need to be really solid at this for the remainder of the year. So I want to just take our time, make sure we do this right. All righty, so we have 1/4 times u to the -6 over -6 plus c. So -1/24. There we go. -6 plus c. And our u value is 4x plus c. Plug it back in. All righty, so we're doing, hopefully feeling pretty good about this. What if I were to take it now and introduce trig to it? What could you guys possibly do with this one? All right, why don't you guys see what we can come up with, and then we'll talk about it. All right, here we go. So again, there's our inside function. So that doesn't change. We're still going to use the u substitution. So u equals 3x plus 1. But then du equals 3 dx. Well, I only have a dx out here, so I'm going to use a 1/3. So our u substitution works with trig just as well as it does with power rules. So this ends up becoming sine of u times 1/3 du. So trig works just as well. And I like having one rule that kind of ties it all together. One ring to unite them all. We have one rule that ties them all. Oops. There we go. All right. So the derivative, or the integral of sine, be careful. I know some of you guys probably put cosine, but remember, it's negative cosine. Gotta be very careful to remember what our integration rules are. Plus c. So negative 1/3, we can go ahead and plug in our u function back in now. Cosine of and so where is that at? There it is, 3x plus 1. I don't know about you guys, but this one down here makes me a little nervous here. So whenever I see two trig functions that are taken to exponents, I always take the bigger one. As a general rule of thumb, I take the bigger one and make it an exponent. So I rewrite that one. So if I do that, whenever I see a bigger two trig functions with exponents, I always take the bigger one and try to rewrite it. Because now, let's take a look at it here. There's my inside function. So tangent, I would say that u would be equal to that inside function, tangent of 4x. So therefore, then du, derivative of the outside is secant squared times 4x times the derivative of the inside. And if you notice, friends, we're really close to having that right there. We got to take that 4 and move it to the other side. So 1/4 du equals secant squared 4x dx. And I think that's just pretty darn cool because it turns out this entire thing really honestly wasn't a trig rule after all. Turns out it was just a power rule. All right, so move the 1/4 the outside again. Pretty darn slick if you ask me, friends. I'm a big fan of this U-substitution. So by now, we also are getting hopefully really good at what the power rule is for integration. So we end up with 1/20th u to the 5th plus c. And we plug our u back in there. Tangent of 4x. Okay, just a couple more for you all to kind of play with here. We're just building this idea of various functions here. Building this idea of U-substitution. These will be our last two problems of the day. All right. Well, you know what I'm going to do. I'm always going to rewrite it. So x plus 2 to the 1/2 times x dx. All right, so we got to get an inside function. I can see my inside function pretty clearly. So u equals x plus 2. And du equals dx. Now, friends, I don't know about you, but that's a little confusing. If I do my substitution and put it back in there, I have my u to the 1/2. I have my du over here, but I still have this x. I don't want that x there, friends. I need to figure out how to take my x and write it in terms of u. Let's go back to what u was. U was equal to x plus 2. That's what we defined it to be. So that means u minus 2 equals x. So in place of this x right here, I could plug in u minus 2. And now I can take this exponent here and I can distribute the u to the 1/2 into this entire thing and create something that I can potentially go ahead and integrate. So u to the 3/2 minus 2 u to the 1/2 du. All righty, so, oops, don't want to do that. We go ahead and we do our integration. So 2/5 u to the 5/2 minus 2 times 2/3 u to the 3/2 plus c. And friends, we plug our u back in. Notice we got to plug it into 2 spots though. Minus 4/3. So we take that, and in place of u is x plus 2. All righty, friends. Why don't you guys pause the video and see how you do with this one at the bottom. All right, let's see how we did here. I'm going to rewrite it. Then I have an x plus 4 dx. All right, find that inside function again. We are hopefully getting a little bit better with this now. So u is x minus 1. That means du equals dx. So u to the 1/2. Still have this x plus 4. And dx became du. And again, I don't want that x plus 4. So I have x. Remember, we had u equals x minus 1. So now I have u plus 1 equals x. But I don't want plus 1, I want plus 4. So I'm going to add 4 to both sides. Like that. So now I got my x plus 4. That means that I have u plus 5 equals x plus 4. So this is usually how I like to do it, where I'll balance it out over here. If you wanted to, what a lot of people like to do, I'll be honest, what a lot of people like to do is they'll just take this u plus 1. And they just plug it right on in there. So you get u plus 1 plus 4. Either or, it's really honestly whatever works best for you. But u plus 4, what I really wanted to have is u plus 5. And we're going to distribute it in. So u to the 3 halves plus 5u to the 1 half du. So 2/5 u to the 5 halves plus 5 times 2/3 u to the 3 halves plus c. So we end up with what u was at the very beginning, x minus 1. So there we go. All right, friends, this is an U-substitution for indefinite integrals. So you guys, once you guys try a little bit of that on your own or start the bookwork a little bit, but we'll talk more about it tomorrow morning, and I will see you then.